Now we will see the factors associated with signal attenuation mechanisms. The factors associated with signal attenuation mechanisms are: first one, absorption. First one, absorption, which leads to the attenuation. Eventually, attenuation leads to the signal degradation in optical signal degradation. Now we will see what causes the absorption. What are the factors causes the absorption? So the basics of material absorption are: we need to focus on fabrication process of the optical fiber. So first of all, you need to focus the fabrication process of the optical fiber, and second is, due to some defects in material distribution in the optical fiber, the transmitted light dissipated as heat. The transmitted light dissipated as heat. So absorption is mainly due to fiber material. Absorption is mainly due to fiber material. So there are three important mechanisms which leads to the absorption. First one is absorption by atomic defects in glass compositions. Absorption by atomic defects in glass compositions. Extrinsic absorption by impurity atoms in glass materials. Second and third one is intrinsic absorption by basis constant atom of optical fiber. Intrinsic absorption by basis constant atom of optical fiber. These three mechanisms causes the absorption. Then absorption leads to the attenuation. Eventually, attenuation leads to the signal degradation in optical fiber. Signal degradation in optical fiber. So now first we will see absorption by atomic defects in glass compositions. So this absorption by atomic defects in glass compositions, now we will see atomic absorption by atomic defects in glass compositions. So these atomic defects are imperfections in the atomic structure of the fiber material. So what is the fiber material? So glass is the fiber material. So atomic defects are imperfections in the atomic structure of the fiber material. So what are these atomic defects? These atomic defects are: first one, missing molecules. And second one, high density cluster of atom groups. High density clusters of atom groups. And third one is oxygen defects in glass fiber. Oxygen defects in glass fiber. So these absorption losses arising from these three factors are negligible compared to intrinsic and extrinsic absorption. Intrinsic or extrinsic, this impurity is nothing but extrinsic absorption. So they can be significant if the fiber is exposed to ionization radiations. They can be significant if the fiber is exposed to ionization radiations. So these three factors or defects does not have much impact on absorption compared to intrinsic and extrinsic absorption. And next one is extrinsic absorption by impurity atoms in glass materials. Extrinsic absorption by impurity atoms in glass material. So this is one of the dominant absorption factor in silica fibers, is the presence of minute quantities of impurities in the fiber material. So the dominant absorption factor in silica fibers is the presence of minute quantities of impurities in the fiber material. So these impurities include OH ions dissolved in the glass. OH ions dissolved in the glass. And second one is transition of metal impurity ions such as iron, copper, chromium and cobalt. So OH ion impurities in the fiber, OH ions impurities in the fiber preform results mainly from oxyhydrogen flame. Oxyhydrogen flame used in the hydrolysis reaction of the SiCl4, GeCl4 and PoCl3 materials. So next one is intrinsic absorption by basis constant atom of fiber. This intrinsic absorption is associated with the basic fiber material, that is the pure glass. So you need to consider there is no density variations and inhomogeneities. There is no density variations and inhomogeneities. This absorption mainly results from electronic absorption in the electronic absorption bands in UV region, electronic absorption bands in the UV region and atomic vibration bands in the near infrared region. First one is electronic absorption bands in the UV region and second one is atomic vibration bands in the near infrared region. Now we will see what is electronic absorption band. So this electronic absorption occurs when the photon interacts with an electron in the valence band. When the photon interacts with an electron in the valence band and excites it to a higher level. This electronic absorption is associated with the band gap of the material. One is ultraviolet absorption. It decays exponentially with increasing wavelength. It decays exponentially with increasing wavelength lambda and is small compared with the scattering loss and are small compared with the scattering loss in the near infrared region. UV loss dB per kilometer at any wavelength as a function of mole fraction of GeO2 is alpha UV is equal to 154.2 x by 46.6 x plus 60 into 10 power minus 2 exponential 4.63 by lambda wavelength. So this ultraviolet absorption decays exponentially with increasing lambda, and is very small compared with scattering loss in the near infrared region. So lambda. And the inherent infrared absorption is associated with the vibration frequency of chemical bond between the atoms of which the fiber is composed. So the inherent infrared absorption is associated with the vibration frequency of a chemical bond between atoms of which the fiber is composed. The absorption causes by interaction of vibration band and the electromagnetic field of the optical signal results in a transfer of energy from the field to the bond. This absorption is quite strong because many bonds present in the optical fiber. Examples are GeO2 and SiO2. Representation for attenuation in infrared region 7.81 into 10 power 11 into exponential minus 48.48 by lambda. Alpha IR is equal to 7.81 into 10 power 11 into exponential minus 48.48 by lambda. This is about absorption. So absorption is basically due to atomic defects in the glass composition, and second mechanism is extrinsic absorption by impurities in the glass material, and third one is intrinsic absorption by basis constant atom of fiber. So these mechanisms leads to the absorption. Eventually absorption leads to the attenuation. Finally due to absorption it leads to the attenuation. Eventually it leads to the signal degradation in optical fiber.